Hi everyone, our next topic will be fundamentals of DC circuits. In this video, we will look at a simple circuit, and then we'll look at how to combine resistors in series, and how to combine resistors in parallel. So what is a simple circuit? Well, a simple circuit is a circuit that consists of a single voltage source and a single resistor. So by the same reasoning, a complex circuit will be one which comprises of multiple voltage sources and possibly multiple resistors. So let's begin by looking at the schematic diagram of a simple circuit. So schematic diagram refers to how a circuit is represented in a simplified format without drawing the real life pictures of the different circuit elements. So for instance, a resistor is commonly denoted by the symbol. A battery is denoted by this symbol, and in this notation this will be the positive terminal and this will be the negative terminal of the battery. A wire is denoted by a straight line, and if we put this together, a simple circuit will look like this. So this is a simple circuit. So here is your resistor and here is your voltage source, and as discussed previously, the direction of conventional current will be as indicated. And of course, Ohm's law states that the voltage across an ohmic resistor is equal to the current times the resistance. So a complex circuit will look like this. So this is an example of a complex circuit. We have more than one voltage source. We have multiple resistors. So next, let's look at series and parallel combination of resistors. So A, resistors in series. So basically, given two resistors, so this is R1 and R2, and let's say a voltage source V. There are two possible ways in which these two resistors could be combined. So let's look at the series combination first. In the series combination, so the two resistors will be joined end to end and then connected directly to the voltage source. So we have R1, R2, and then we have V. So when resistors are combined like this, you would say that these resistors are connected in series. Now here are the characteristics that make a series combination different from the parallel one. In a series combination, as you can see, starting from the positive terminal of the battery, we have a single conducting path. So number one, single conducting path. That means if one of the elements in the circuit is broken, then the whole circuit becomes dysfunctional because we have just a single path. So think of a road, let's say driving on a road that has no exits. If there is an accident on the road, then the whole traffic comes to a standstill because there is no outlet. So that is similar to a series combination of resistors. For instance, in your house, if all your light bulbs were wired in series, if one bulb burns out, then the whole house will have a blackout because the whole circuit will not work because there is a breakage in the circuit. For a circuit to work, there must be a complete conducting path from the voltage source through the circuit and back to the voltage source. A consequence of the single conducting path is that every resistor has the same current, or we could say the same current passes through every resistor. because based on the law of conservation of charge, charge cannot be created or destroyed. Therefore, for any element in a circuit, in a series circuit, the current will be the same. A third characteristic is that the voltage drop or potential difference across different resistors adds up to that of the source. So, for instance, in this diagram, the voltage drop across the first resistor, let's call it V1, and then the voltage drop across the second resistor, let's call it V2. So V1 is, let's say, the voltage from here to here. V2 is the voltage from here to here. So if we call this, let's say, A, B, and C. So from A to B we have V1, from B to C we have V2. And notice that A is directly connected to the left terminal of the battery, the negative terminal, and C is directly connected to the positive terminal of the battery. Therefore, the voltage between A and C is simply V, which is equal to V1 plus V2. So for a series circuit, the voltage of the source V is equal to V1 plus V2, but I1 is equal to I2. So the voltage doesn't have to be the same for the different resistors, but the current must be the same. Now let's look at parallel combination of resistors using the same resistors R1, R2, and a voltage source V. If R1 is placed parallel to R2 and the two ends are tied together, this is my R1, this is R2, and then a common wire is used to connect the group to the voltage source. Then what we have now is a parallel circuit. So this is V, this is R1, that's R2, and any current leaving this voltage source, so let's call this I. At this junction there are two options, which means the current will split up at this junction into a current, we'll call this I1, the current through R1, and then another current I2, the current through R2. And this current will recombine here to give I, which is the current from the source. So what are the defining characteristics of a parallel circuit? Number one, we have multiple conducting path. So there are multiple ways to leave the voltage source through the circuit and back to the voltage source. And an illustration here would be, a road that has an exit. So a car arriving at the exit will have the option to continue on the main road or go through the exit. So the sum of the two currents at the junction, leaving the junction, must equal, the current entering the junction. In the same manner, in the traffic analogy, the number of cars entering a junction has to equal, the number of cars exiting, the two paths from the junction. So number 2 characteristic is that I equals I1 plus I2. Next, let's look at the voltage. So pay attention to how the negative terminal, so this is the negative terminal of this battery is connected to this point, which is common to R1 and common to R2. The positive terminal is connected to this point, which is also common to R1 and R2. So what that means is that the voltage V across the source is applied directly across R1 and R2 at the same time. So this means that V1 is equal to V2, and that is equal to the voltage of the source. Consequently, for a parallel circuit, the voltage is the same. The voltage for each resistor is equal to the voltage across the source. So this is how you distinguish between series and parallel circuits. And one of the learning objectives in this section is that students, after completing this module, will be able to distinguish between series and parallel circuits. In other words, you should be able to look at a circuit and say how different resistors are connected. Next, let's look at how to combine resistors in series. So the formula for combining resistors in series is R equals R1 plus R2 plus R3 plus up to any number of the resistors in the circuit. So for instance, given a circuit with 3 resistors connected in series, so let's say this is 5 ohms, this is 10 ohms, this is 5 ohms. So the equivalent resistance here, so let's say V is 30 volts. So the equivalent resistance, remember this EQ means equivalent, that means the single resistor that has the same value as all the resistors in the circuit combined. So the equivalent resistance will be equal to 5 ohms plus 10 ohms plus 5 ohms, which is equal to 20 ohms. And since the voltage is 30 volts, the current in the circuit, according to Ohm's law, would be equal to V divided by Req, which is 30 volts divided by 20 ohms, which is 1.5 amps. So a current of 1.5 amps will flow in every element in the circuit. Now, let's look at combining resistors in parallel. Let's start with the simplest case, 2 resistors, and then we'll move to 3. So suppose we have this. And this is 2 ohms. This is 1 ohm. So the formula for combining resistors in parallel is Req equals 1 over R1 plus 1 over R2 plus 1 over R3 to the power minus 1. So you add the reciprocals of the resistors and then take the reciprocal of the sum. Okay, so in this case we have just 2 resistors, so we're going to apply the equation up to R2. So Req will be equal to 1 over 1 ohm plus 1 over 2 ohms to the minus 1. So that is 1 over 1 plus 1 over 2 is 3 over 2 to the minus 1, which is 2 over 3. So the equivalent resistance is 2 over 3 ohms. So what this means is that this circuit shown here is the same as a single resistor of value 2 over 3 ohms wired in series with a battery of 10 volts. And of course, the current will be voltage divided by resistance, which is 10 volts divided by 2/3, or 10 volts times 3 over 2. Remember, the rule for dividing by a fraction is you flip the fraction and multiply. So 10 times 3 over 2 will give us 15 amps. Now let's look at another 3 resistors. Notice that this is also a parallel circuit. So all three resistors, you can clearly see that the you can clearly see that both lower ends of the resistors are wired to the same point in the battery, and both upper terminals are wired to the same point, or the positive terminal of the battery. So the equivalent resistance in this case will be 1 over R1 plus 1 over R2 plus 1 over R3 to the minus 1, and this is 1 over 1 plus 1 over 2 plus 1 over 4 to the minus 1. Now you can rewrite 1 over 1 as 4 over 4. 1 over 2 is the same as 2 over 4, and then plus 1 over 4 minus 1. So this is 7 over 4 to the minus 1, which is 4 over 7 ohms. So that's the equivalent resistance of this circuit. So again, that means that you could replace this whole setup with a single resistor of value 4 over 7 ohms, and you will obtain the same effect. So let's just say the voltage here was 4 volts. Then the current that will flow is a V divided by R equivalent, which is 4 volts divided by 4 over 7 ohms, which is 4 volts times 7 over 4 ohms. And that is 7 amps. So with this, you should be able to, combine any number of resistors in series and any number of resistors in parallel.